Good morning, students. So today we are going to see a case study in our topic linear algebra and calculus. So the title of the case study is Google PageRank. Okay, so already we may familiar in the name Google. So Google search engine. So whatever we need to find out, whatever we don't know in the subject, and whatever we must know means always we will Google it. So that is the main reason. Okay, right. So just a little information about Google. Okay, Google first name was the Google first name is Google, Googol. So what is Google? Google is a number according to mathematics. 100. What is 100? 100 is 1 followed by 2 zeros. What is 1000? 1 followed by 3 zeros will be called as 1000. 1 followed by 5 zeros will be called as 1 lakhs, and so on. And Google is same as Google is nothing but 1 followed by 100 zeros. Okay, just assume the number. So why the search engine first named it as Google means it contains that much of information related search they are having. That is the implication from that. First they are named as Google, and later on they modify it as Google. Okay, and this is the story of Google becomes Google. Then Google's web page was first launched in the year 1998 by Sergey Brin and Larry Page. These two are the important person in framing this search engine. Okay, and we know the dramatical success of this Google page. So extraordinary success of this with Google page. So the extraordinary success of Google page depends on the clever use of eigenvalues and eigenvectors. So this is what we are saying here in this chapter. So we already know how to find out the eigenvalues and eigenvectors mathematically. Now we are introducing these eigenvalues and eigenvectors in Google, relating these terms into a Google PageRank. Okay, so first Google did not think about the PageRank initially. They did not empathize it in the beginning, and later on they empathized, defined, and ideate all those things, and they, in a design thinking manner, they have considered the PageRank later on. Okay, so the PageRank is not really a factor anymore in the way it was at the beginning. So this is the main thing. Okay, so now let us consider an example. Okay, right. So just for our discussion, what I am considering is, just to consider we are having 6 web pages relating to a specific content. So page number 1, page number 2, page number 3, page number 4, page number 5, page number 6. So what does this arrow implies? So page 1, author thinks that they are having some relevant content in page 2, page 6, page 5, and page 4. So that page 1 is linked with page 2, page 4, page 5, and page 6. Similarly, the author of page 2 thinks that the page 2 is linked with page 3 and page 4 only. The author of page 2 thinks that they are having some relevant content in page 3 and page 4. And similarly, page 3 author thinks that they are having relevant content in page number 5 only, and so on. This is the implications. Okay, so just consider, for the sake of, we are having only 6 pages to understand the concept of PageRank, how Google's PageRank works. That is the main thing. We are assuming the links between these and other pages in the simple web or summarized in this diagram. Okay, right. Google engineers assumed that each of these pages is related to some way to the other pages, since there is at least one link to and from each page in the web. Okay, so that is the main reason. Okay, the main task, what is our main task? We have to the main task is we have to find the most important page for a particular search keyword. Okay, that is the main thing. So whatever we are searching, it has to come at the top. So once if you are searching, it goes at the bottom of the page, means you won't prefer that search engine. That is the main reason. Okay, so this is the main task. The task is to find the most important page of that particular search engine, right? However, some other cases may be allowed. And how the page rank works, the beauty of the page rank. What is the beauty of this page rank is it is regarded, page rank is regarded pages with many incoming links. How many incoming links once the author is getting, it's relevant to the page of that rank of that page. That is the main thing, especially from other popular pages, not from any mediocre pages. That is most important. Once if your pages are referred by a popular pages, means you will get your top rank, and the mediocre pages means you will get the low rank. That is the main reason. Okay, okay. So you have to give some weightage to the paragraph. Okay, now I am representing this graphical representation into a vector and named as linked vector. Okay, so what is the linked vector of 1? Okay, linked vector of 1. So how I am writing it as vector? Once if a page is linked to your other page, I am writing it as 1. Once the page is not linked to the other page, I am writing it as 0. Okay, so my entry will be either 0 or 1 according as it is linked to the particular page or not. That is the main thing. Okay, right. Now I am writing the link vector for page number 1. So what is the link vector? The page number 1 is not linked with itself. Any page is not linked to itself. So the value is 0 to the corresponding. So 0. So 1 is linked with 2, it becomes 1. 1 is not linked with 3, it becomes 0. 1 is linked with 4, 5, and 6. Therefore, the link vector becomes, link vector of page 1 is 0, 1, 0, 1, 1, 1. Similarly, for page 2 is 0, 0, 1, 1, 0, 0. That means 2 is linked with page 3 and page 4 only. And what is the page link of vector? Link vector of 3? Link vector of 3 is 0, 0, 0, 0, 1, 0. And a page vector of 4 is similarly 0, 0, 0, 0, 1, 0. That means 4 is linked only with 5. And what is the link vector of 5? 1, 0, 0, 1, 0, 0. Okay. Then last, finally, 6, 0, 0, 0, 0, 1, 0. Since 6 is linked only with 5. So this is the link. I am writing the link vector of the matrix. Okay, link vector. Okay. I'm considering these all vectors as a matrix. That matrix I am calling it as a link matrix. So how I am representing it as matrix? Okay. So I'm converting the graphical representation of this problem into a mathematically I'm formulating into a my problem, my own problem. I'm considering the link matrix as A. So what is A? A matrix is 0. So first page author 0, 1, 0, 1, 1, 1. What is the page link vector page 2? 0, 0, 1, 1, 0, 0. Third page is 0, 0, 0, 0, 1, 0. Fourth page is 0, 0, 0, 0, 1, 0. Fifth page is 1, 0, 0, 1, 0, 0. And last page vector is 0, 0, 0, 0, 1, 0. So it's a 6 by 6 square matrix. We know, you know how to find out eigenvalues and eigenvectors of a square matrix. So already we have the problem session is over. Now we are in the case study. So this is the corresponding matrix of this situation. Okay, right. Now how I am getting the matrix? So now this is the link matrix, and this considering the matrix, and just what I'm here, what I am doing, I am searching for the most relevant page. So how I am getting the most relevant page? We have to go for probability. So just to think that, just to consider these pages. Okay, first page. So out of 6 pages, only 4 pages relevant to this page. Okay, so what is the probability? 0 by 4, 1 by 4, 0 by 4, 1 by 4, 1 by 4, 1 by 4. So when you sum up, you will get answer equal to 1. And similarly, what is the probability matrix of this column? Only 2 pages relevant. So 0 by 2, 0 by 2, 1 by 2, 1 by 2, 0 by 2, 0 by 2, and so on. So I am representing this matrix in a probability matrix. Okay. So just this is the final matrix. I am mathematically formulated my situation into a matrix. So for this matrix, what I am doing is I am going to find out the eigenvalues and eigenvectors. Okay. So once if we mathematically formulated our problem, means solving is the skill that we are already doing in the blackboard. Okay. So solving, how to find out the eigenvalues, you know, a minus lambda I equal to 0, you will get a polynomial equation, and solving this polynomial equation, you will get 6 roots. So this is the roots of this equation. Roots of this equation will be called as eigenvalues, that we know. So what is the expression? So here our aim is ranking the page. Okay, so while ranking the page, we have to consider non-negative real values. Is it correct? So we have to think of ranking, means we have to think of non-negative real values. Ranking does not contain a negative values, 0 or a complex number, so on. So anything that comes means we have to omit it, and we have to consider the non-negative values. So just here, the only non-negative value is 1 here. So only eigenvalue is 1 here. So for corresponding to lambda equal to eigenvalue, corresponding to this eigenvalue, I have to find out the eigenvector. Is it correct? Then, so for corresponding to eigenvector, I am having V1. So that is, what is the corresponding eigenvector? 4, 1, 0.5, 5.5, 8, 1. That is the vector, column vector. So I am repeating this transpose. Okay. So here 4, 1, 0.5, 5.5, 8, 1. It represents the corresponding page of that vector, eigenvector. So out of this, 8 is the highest value. What does it imply? This is the first page, this is the second page, and this is the third page, and this is the fourth page, and this is the fifth page. So fifth page is having the relevant content. So the highest rank of that fifth page is having the highest rank. So fifth page will be appear on the top of the search. Okay, so this is how Google search engine works. So just we normally typing and doing all those things, but with clever mathematics and clever optimization techniques only, what we are searching, what the relevant content we need, that should appear on the top. Okay, and these are all the computer programming that works behind the screen, eigenvalues and eigenvalues. So whenever you are searching something in the Google, think of eigenvalues and eigenvector. So that they are calculating using that eigenvalue and eigenvector, they are finding out the page rank. So for this example, I am considering only 6 pages, but Google, Microsoft Bing, Yahoo, and whatever search engines you have, they cope up with billions of pages they will have. So that requires computing power, clever mathematics to optimize the process. That is most important. So without this process, no one will come at the top. Okay, so Google currently using 200 different signals for this web pages, including page speed, keyboard, and so on. That are all those things they are using. So they constantly revise those signals to beat black hat operators. What is the black hat operators? Who try to game the system to get on the top. So they are trying and constantly revising those signals. That's why Google search engine is at the top while searching for anything. So most of the persons are searching in Google. That's why they are preferring Google for searching anything for them. Okay, so this is the main purpose. So this is my references, and these are my suggestions for further reading to you students, and hope you will enjoy it. Okay, thank you. Goodbye.